Okay, we shall now have our lesson 3 about time travel and go a little bit further and introduce some new concepts. So, damn it. Forecasting can be made using information from the past to figure out some information from the future without any information being sent from the future. So we are still keeping our instance. Okay. And we remember that we could be anywhere here. How can you tell if you are here, here, or here? So this line is very important because it doesn't depend on time. So at one instant you could have some kind of new dimension or some sense. Some people talk about the sixth sense. That could be that you could just travel on this line at the same moment, and this giving you a different perspective of what the future could be. And let's see it in another way. If you try to figure out what's the weather gonna be like tomorrow, you shall look what's the past weather been, and you can see that you can have, for example, some summer, then some winter, then some summer, then some winter, and so the temperatures will rise, and so you can easily figure out from anywhere, and even from this point of view, what the summer, when the summer is going to come. But in fact, when you think about the future, the idea is that in fact you need to be in a place where you are thinking about this future. So if I'm figuring out what's next summer gonna be like, let's imagine at that point, this means that I would need in fact to be in this timeline and not in this. So the simple fact of thinking about the future could be a way of traveling. And so if I'm just thinking about what's Earth going to be like in 1,000 years and try to figure out how human beings will be, what they will look like, what will their technologies be like, then it would really send me very far here. So this could be a way of moving around this line. Second important idea of this lesson 3 is that you can see here that we are stretching this line very far, and we haven't dealt much with the past. Is it we just say that the past was the same here, that there was some kind of equality relationship between all this. Here you can sense that there's a problem because you are stretching something in this direction and nothing changed before. And so if you are changing something in this timeline, you obviously something should change before. And so here you have two different models that work relatively good depending on what you are looking for. The first model, which is the simplest, is that you are just saying that you've got a second time wall. So you've got your time walls going there. So you've got a first time wall, and then you got a second time wall. And in fact, the fact of forecasting, thinking about the future, then you could think about the past in the same way. And the problem of this hypothesis is that you couldn't have in the same set of mind thinking about the future and the past at the same time beyond a certain point. For this reason, this model is relatively weak. And also, there's a reason for there being, a second time wall in the past. Obviously we know that it's not. It contradicts our knowledge in physics about, we know when the Big Bang came. And in fact, the time wall would be more like this. It would be the Big Bang, in fact. And how could we match this kind of time wall that we call the Big Bang very long ago, and with these instants stretching over and over? And in fact, the idea is that you've got the same amount of, let's call, we could call it time stuff, but this will be an introduction to time quantums, which is some already accepted concept. So it's a very interesting concept in physics that is already accepted. And so you would have this time wall and a quantity of, it's not energy, it's not matter, but it's some kind of stuff time is made of. And you've got the hypothesis that you've got this same amount of, let's call it time stuff. We'll try to figure out about a more adequate name later on. And that if you stretch here, then you would have to weaken the time. And this is why you could draw it in dotted lines. And these dotted lines represent the fact that the past weakens. The past vanishes like old memories. And this is this model can be related through the way our mind figures out the time, and we forget things from the past. And this forgettiveness could be linked to the fact that the stuff weakens, and there would be some mathematical distribution that lowers, but it doesn't completely block. So this is why we couldn't have, two parallel time walls, although this model of, conservation of stuff across the time the time wall, the stuff must be the same. But so you could just say it's a naive model that's fine from a certain point of view, but a better model is just to say that you will have some weak time, and it can be just a very thin line, and that goes thicker across time. And in fact, you've got this thickness. Time becomes more thick as close as you get from the instant. Okay? And it weakens and becomes, your old memories. And so this is an opening beyond physics. It's an opening about how our brain functions, and hypothesis, but that will be dealt furthermore in a next lesson, is that our brain doesn't contain the information of the past because it's always moving. It's just blood flow and electrical movement. And the fact that the brain is always moving, changing state, is completely it is not adapted of stacking information from the past. And in fact, the brain could be some kind of time machine going back to the past. And in fact, when you think about some old memory, in fact, your brain fetches the memory in the past. Some good memories can fetch very accurately because they can go back. In fact, you see that they have a possibility of retrieving information even from a very thin line. You can have some accidents. If you have some brain accident, or if you have some drug history, and you can have some difficulties of retrieving information from the past because there's some accident that happens at some stage and that prevents you from getting the right information. You know that information ought to be there, but your brain isn't capable of fetching the information because of these, accidents blocking stuff. So I think this is enough for the third lesson. It's a little bit messy, maybe. This is just a first edition, and we'll have something cleaner as soon as we've got our ideas a little bit repackaged. Okay, hope to see you soon. Cheers all.